This video answers the question, what is a function? A review of an important concept taught in Algebra 1. You will use this video to understand what is or is not a function, write your class notes, and prepare for next class's knowledge check. Relations and functions have inputs and outputs. The inputs are the x values, also known as the domain. The outputs are the y values, known as the range. Relations and functions may be represented many ways by tables, ordered pairs, data maps, equations, and graphs. All functions are relations, but strangely, not all relations are functions. So we're going to study this slide, and I'm going to tell you that everything on here is a relation, but only a few of these things are functions. So look at the tables, ordered pairs, data maps, and try to figure out what pairs of x's and y's make functions. I'm going to give you a little quiet time to do that. There's one unique characteristic we are trying to see. We're going to look at a function machine. I got this from one of my teachers that I used to work with, Christina Howard, and she had this video she used to show her students. So I've taken pieces of this video to help you see what is a function. At G, this is a data map that shows a function. Why is it a function? Strange, there's no x in the equation. Every time I put an x in, it comes out as a 6. It's a horizontal line. Okay, I want you to restudy this slide and rethink. Can you tell a difference between a relation and a function? Again, all of these are relations, but only C, F, G, and I are functions. I'm going to give you some quiet time to think about it. We are looking for one key component. Why are these functions? Well, a function is a unique relation where any input x yields one and only one output y. In other words, an x value input into an equation can only give you back one and only one y value for the equation to be a function. Now, instead of looking at data maps and tables, we're going to look at graphs and equations. Can you tell, based on our definition of a function, which graphs and equations below are functions? Again, all of these are relations, but why are only some of these functions? Well, in Algebra 1 and Geometry, you probably learned this test. It's called a vertical line test. If I take a vertical line and I drag it across my graph, if it hits in two places, it's not a function. But if it only hits in one place as it's dragged across, it is a function. So B is not a function because it hits it in two places. That vertical line hits the function in two places. For given a value of x, there's two possible y values. But C, as I drag the line across, it only ever hits one y value, so it is a function. For a given value on the x-axis, there is only one possible y value. So using the vertical line test and our definition of functions, let's relook at this. Also on the equations, the hint is you might want to try graphing the equations to see what they look like and then use the vertical line test. Which graphs are functions below and equations? Well, only A, C, D, F, and H are functions. See if you can tell why, and if you have any questions, ask me next class. Some other things about functions you need to know. The x variable is known as the input, the domain, and also the independent variable. The y is known as the output, the range, and also the dependent variable. You may replace y with f of x and call an equation f of x equal. Consider the equation y equals 3x plus 4. I could rewrite it as f of x is equal to 3x plus 4, which is the function definition. To solve for y, you have to input an x value. That makes x independent. So let's say, for instance, that I give you x equal 2. I have to substitute that 2 in for x in order to find my y, or my dependent variable. In this case, then, y is equal to 3 times 2 plus 4, y is equal to 10. I'm going to let you do one. We're going to use the same equation, y equals 3x plus 4, but instead of a 2, we're going to say x is a negative 3. I want you to figure out what is y. Let's see what we had to do. I substituted in the negative 3. 3 times a negative 3 is a negative 9 plus 4. Y is a negative 5. So now that you've reviewed substitution, let's go back to the function machine and see if you can quickly guess the output y for a given x. One more thing about functions. In later units this year, we may give you ordered pairs, a table or data map of inputs and outputs, and you will need to recognize their pattern to derive the function's equation, also known as the function rule or explicit rule. So let's go one last time to our loud and noisy function machine to see if you can guess the equation for the given inputs and outputs. This video answered the question, what is a function? I'm Mrs. D, and I look forward to seeing you next class. Hopefully you saw that the last function machine gave you y equals x squared, which is a quadratic parent function that we will be studying later this week.